Yeah, it started. Yeah,
Yes.
okay. Okay, all good. So we are good to start. Hi all, thanks for joining this morning and a warm welcome all to the ISTQB training series. So for the benefit of those who are attending the session for the first time, let me explain. So we had two sessions back to back in the last 2 weekends. So in those sessions, we covered the ISTQB first module. So basically in the ISTQB sessions, we have 6 modules. So in the first 2 weekends, we covered the first module, which is fundamentals of software testing. So today we are going to start the second module, which is testing through the software development lifecycle. Before jumping in the session, let me set the context first. So during the entire session, we'll mute all the participants because we have multiple members are joining. So unmuting everybody and addressing all the queries will not be that easy. So for the sake of handling the session, we would mute all the participants and we can have all our real-time interactions through our chat box. So all the participants, we welcome all to the chat box where we can um, post all your queries and we are more than happy to address all your queries. So please be alert with our chat box there. We welcome everybody to post your questions and we will definitely address all the questions. Okay, so Suma, maybe over to you. You can start with the software development lifecycle testing through.
Thank you, Joe. So, hi everyone. A very warm good morning to all of you. So, we have already had our ISTQB training sessions going on since last 2 weeks. And here we are with the part 3 of the series. So, in case if you haven't already attended the previous sessions, you can always visit our channel and go through the sessions anything. So, we will move to our topic. So today we will be starting with the module 2 of the ISTQB syllabus. So before we get into the topic, let me just ask you, what is a background? What is the experience you have in software testing? You can put on the chat box. So what is the experience or background you have? Because you know why we are all here. Yeah.
We have a legacy of 13 years experience and 4 years, right?
Okay.
Okay, so legacy of 13-year experience means Parvati having maybe started with Waterfall Model, then V Model, and now in the age of Ajay. So Parvati should be going through all these transitions through all these SDLC models.
Yeah.
That's good. Yeah, basically, Suma, we have a mixed crowd here.
So you will all be very much aware how important it is to have the ISTQB certification these days for the software testing profession. So that's why we are all here and we'll move to the top. So today we'll be discussing the module 2, that is the testing throughout SDLC. So in this module, we'll be covering different SDLC models, test levels, different test types, and the maintenance testing. Yeah. So before we actually get into the different SDLC models, so first we have to see like what are the good testing practices. So let me just ask you, like in your company, since you're all experienced, in your company, like is there anything like good testing criteria which is to be followed? Like for every requirement, you are supposed to do these many activities, or you have to do the test execution twice, or something like that, to make the your practices like better. What are the testing, good testing practices which is followed in your organization?
Any specific practices that you're following? Anything related to testing?
And that can be anything. Like, there can be some criteria set up by the
Okay.
organization or by the process. Okay. So, we all know, like, there is actually no hard and fast rules, like, or steps, which exactly, if done, is going to make our testing better or accurate. But of course, there are few good practices, which, if we followed, is going to make our test best look better. So we'll just go through what are those practices. So the first point is, for every development activity, there is a corresponding testing activity. So what is the first development activity in your project or in any project, any development project? What is the first development activity? Mhm. What is the first development activity? So we know, like, for any project, it will be the requirement, the collection or collecting of the or capturing of the requirements. So it would be the requirement analysis. So during the requirement analysis phase, what would be the testing activity you would be engaged in? As a tester, what would be the testing activity we will be engaged in? Exactly, Parvati. So analysis or requirement collection. The collection or capturing of the requirements is the first step which is happening in any software development process. So what would be the testing activity as a QA or a tester we would be engaged in?
Parvati mentioned requirement walkthrough,
Yeah.
maybe test case
There will be a
analysis.
requirement walkthrough. Exactly. There would be meetings happening during the requirement analysis phase with all the team members. So different companies would be calling these meetings by different names. Like, basically, what we are all doing is all the team members will be joined together to discover and explore, like, what exactly we are going to implement in this particular epic, or what are the functional areas that is going to get impacted, to check if there is actually any functional or non-functional dependencies for implementation. So in turn, we are actually reviewing the requirements, right? As a QA or a tester, we are actually reviewing the requirements and see how it is going to get implemented. So actually, a testing of the requirements is happening there, or a reviewing of the requirements is happening there. Similarly, we will be having a testing activity for every other development activity. It's not just the requirement analysis. We'll be having a testing activity for every other development activity. So we can have a better understanding of this with the V model.
Okay. Suma, maybe we'll take a pause here. So
Yeah.
maybe I will just glance to what all the meetings or uh, practices that we are following the requirement analysis phase in my project at least. So basically, we'll start with a discovery meeting. During the discovery, the PO, product owner, will be explaining what is the exact scope of this particular change, this particular CR. Post that, our FTL along with the SME, there will be another session which is called as explore session. So the SME will be exploring the exact requirement and what are the dependent areas and what are the gray areas and what is the exact implementation that we are planning for and what is the logic behind that. So he'll be exploring that particular requirement. Then after once the explore is done, the SME will be giving you an IA walkthrough, a solution walkthrough for the whole team. So these are all the three activities that will see happening in terms of requirement review, requirement analysis phase in my project. So I could see Parvati commented in her project also there are three ceremonies are happening in terms of requirement.
Yeah. So whatever the different companies name it in different way. The basic thing happening there is a reviewing or like analysis of the requirements. So we can see it through the V model. So here we can see that for every development activity, there is actually a corresponding testing activity happening. So during the requirement analysis phase, the testers would be involved in the requirement analysis to prepare the acceptance test cases. And in the system design phase, when the developers are designing the system, the testing team or the QA will be involved in creating the test cases for the system testing. So that sums up our first good practice. That is, for every development activity, there is a corresponding testing activity. Next is each test level has test objectives specific to that level. So test level is a topic which comes later in this module. We'll just go through it quick. So we know that for the testing practice, we know that there are mainly 4 different levels of testing. That is a component testing, integration testing, system testing, and acceptance testing. So the second good practice is saying that each test level has a test objective specific to that level. So we know that what happens in a component testing. So in component testing, the objective of component testing is specific to find the defects in the code or in the component or the unit. Whereas in what happens in integration, so in integration testing, we are integrating 1 or 2 components and we are verifying that the integrated functionality is working fine or not. So the objective varies from one test level to another. So in acceptance testing, we are verifying if the product can be actually accepted or not. So the objective varies from one level to the other. So that is a second point. That is, for each test level, the test objective is different. It is specific to that test level. For component testing, it is to find the defects in the code, whereas in integration testing, it is to find if there is any issues once 2 components are integrated. So that is the second point. We'll move to the third one. Next is the test analysis and design for a given test level begin during the corresponding development activity. So we have already seen from the V model, for every development activity, there is a corresponding testing activity. And so during each development activity itself, the testing team would be conducting corresponding testing activity. As we have already seen during the requirement analysis phase, the testing team will be involved in the analysis and design of the corresponding acceptance test cases. So the analysis and design for given test level begin during the corresponding development activity. The next is testers participate in discussions to define and refine requirements and design and are involved in reviewing work products. So as soon as the drafts are available. So the point here is as soon as the drafts are available. So what exactly means by a draft? We know that draft is not the final completed version of a document. So it is the first version of the document, which is not actually streamlined or no. So the testers should be participating in the discussions to define and refine the requirements. They should not be waiting until the final requirements are available. They should be involved in all the activities as soon as the first draft is available. So how does this help? Like, what is one advantage from this practice? Like, do you know any advantage if you are involved in the testing team or QA is involved in all the discussions at an earlier stage or as soon as the drafts are available from your experience?
So maybe basically all the test engineers will be getting a high level scenarios at least. At least we'll be getting an idea about what are the scenarios that we can formulate. Maybe that we can take it as an input.
Yeah, right.
To start.
Yeah. So one other thing is like in case if there was a mistake in the requirements captured, and if the team was not involved in reviewing the work as soon as the draft was available, say for example in a banking application, the requirement captured, there was a slight mistake in the interest calculation. So that is going to be a huge issue later on. So the participation of testers should not be just involved just in the test execution part. They should be participating in all the discussions to refine the requirements as well. So in the same case, if we were not identifying the issue initially during the requirement analysis phase, the issue in the calculation of the interest, it is going to get propagated to the coming development phases also, and then that is going to be very difficult and expensive to fix that issue. So the testers should be participating in all these discussions as soon as the drafts are available. They should not be waiting until the final completed document is available. So next is no matter which software.
Suma, one second.
Yeah.
So the Pavati highlighted a point like communication gap. So basically, it's not communication gap as such, but it is with the requirement gap that we'll be able to find out if the testers are participating in all these requirement related discussions and all. Yeah, definitely that's the point. It's a requirement gap that we can identify.
Yeah, exactly.
Yeah,
Yeah.
continue.
So next is no matter which software development lifecycle model is chosen, test activity should start in the early stages of the lifecycle. That almost sums up iterating all the different points we have discussed till now. So like in Agile and V model, the what is being done, the testing principle of early testing is being applied. So this will help in identifying the issues earlier and fixing it early, which is more easy and less expensive. So these are few good practices for testing that is to be followed for the delivery of a quality product. So we'll just read through. For every development activity, there is a corresponding testing activity, and for each test level, it has a test objective specific to that level, and then there is a test analysis and design for a given test level begin during the corresponding development activity, and the testers should be participating in all the discussions as soon as the drafts are available. And finally, whatever software development lifecycle models we are following, the testing activities should always start in the early stages of the lifecycle. So these are the good practices which will help us in having a better quality product. So now we can move to the SDLC model. Is it clear till here? So now we have the different SDLC models. So could you just comment on which are the different models you have worked on or currently working in?
Yeah, team. So you might be going through the different life cycles models, right? So what are them that you actually experience? Yeah, we are all good in theory, I know, but actually, what are the SDLCs that you experienced in your project, in your companies? Can you please comment? So based on that, we can make some more detailed discussion.
Whatever life cycle models you are following in your organization, can be Agile or V or anything.
Yeah, we have Waterfall Model, V Model, Agile. Yeah, these Waterfall Model, V Model, Agile. Anything extra apart from this? Any model?
Agile again.
Yeah, Agile. I think Agile is the most favorite one. Yeah.
Yeah.
Yeah, incremental. Yeah, incremental.
Yeah, there is incremental also.
Yeah, we would expect one more terminology other than this incremental model. We would expect one more model. Any clue? Anybody? We have spiral model. We have iterative model. We have incremental model. Yeah, all good. Thanks for the comments.
So each company or organization will be following different SDLC models. So based on the project or the requirements, so requirements would be definitely differing. So based on all these requirements of the project, it is the development lifecycle models, whatever they are following will also be different. So it is very important that we have a fair understanding about each and every SDLC models. How does it really vary from each other and how testing happens in different methodologies. So in ISTQB terms, the common SDLC models are sequential development model and the iterative and incremental development models. So we'll just go through the sequential development model. So what is a sequential development model? So a sequential development model is described as a software development process which is linear sequential flow of activity. So what do you mean by linear? Linear means like in a line as a sequence. So here each development phase happens in a linear sequence, and each development phase would be started only after the previous stage is completed and approved by all the stakeholders. Like if we have to start the system design phase, the requirement analysis phase should be completed and should be freezed and should be accepted by all the stakeholders. So we'll take the example of different sequential models. So here we have our waterfall model. So waterfall is our legacy traditional SDLC model. So what happens in the waterfall model? So only if we have to start with the design phase, only once the requirement phase is finalized, the next phase, that is the system design, can be started. So there is no overlap or rolling back to the previous phase possible. So there can't be a phase where half of the requirements are done and they have already started with the design phase. That is not possible in the waterfall model. So there is no overlapping phase, and you are in the system design phase and now you want to go back and make some changes in the requirements. That is also not possible. So there is no overlapping phase. There is no rolling back to the previous phase possible. So here, each phase, if the design phase is to be done, it can happen only after the previous phase. That is, a requirement phase is completed and approved by all the stakeholders. That is, it should be frozen. So what is one main disadvantage which can happen from the waterfall model, which is obviously visible from the picture? Do you see any disadvantage that would be affected by this linear sequential flow of activities?
In simple terms, I would say once it is done, it is done.
Yeah, that is one thing. Time, yeah, that is also there. But one important point which we were discussing throughout the good practices.
You mean testing in each and every phase, or participating testers in each and every
Yeah,
phase?
right. Testing. So
Okay.
we have already said that the in waterfall method, the each phase will start only once the previous phase is done and completed and freezed. So we can see that the testing happens only after requirements design and development phase. So in order to be in the testing phase, we should have already completed all the phases above and freezed, right? So the testing is happening only towards the end of the life cycle, which is going to be a huge cost, right? So if there was some issue with the requirements or the design or development, or if there was a issue with the requirements and that actually propagated through the different phases, that is going to be an issue. So testing. So one of the main disadvantage here is that the testing activities happens only after all other development activities are completed. So if there is any mistake in the requirements captured, that is going to get propagated through all the stages, and testing would be happening very late, and that is going to cost a lot. So that was one point which we were iterating through different good practices, whatever we were discussing, that the testing should happen early, as soon as the drafts are available. So next is so waterfall method is one of the main SDLC sequential SDLC model. Next is a V model.
Okay.
So what happens in the V model? So what is the main difference you can see or identify from the waterfall model and the V model? Which is obviously visible from the picture, like you can see it here. So we have already discussed, like testing should be happening very early in all the different life cycle models, and we have seen that in waterfall model it is very unfortunate, it is not happening there. The testing is happening only towards the end of the life cycle. So what is the main advantage or the difference you see from the waterfall model here? Yeah, testing everything. Yes, exactly. Yeah. So Unlike the waterfall model, V model applies the testing principle. So the basic testing principle, whatever we were discussing, is testing principle of early testing. And the testing phase is happening for every development activity. So here we can see for requirement analysis phase, while the BA or other team members would be involved in the requirements capturing and analysis, the testers will be involved in creating the acceptance test design and the acceptance test cases. Similarly, for each development phase, during the system design, the developers would be involved in designing the system, whereas a QA or testing team will be involved in creating the system test design or preparing the system test cases for doing the system testing. So what is the main advantage here? So client, once this is done, the client is going to get a fully completed set of features. But the main disadvantage that here is that the product might be obsolete by the time it is being delivered, because we know that once everything is done, it is going to take a lot of time. It might take months or years. So with the current pace of digital era, like we know every 2 weeks the technology is changing. In weeks time or months time, the technology or the features are evolving rapidly. So if we have decided on few requirements and we are taking a few months or years to complete it, by the time it is actually being delivered to the customer, that is the product is going to look outdated or product is going to be obsolete. So that is one disadvantage. Though the client is going to get a full completed set of features, that might be obsolete by the time it is getting delivered to the client. So that is a disadvantage and advantage of the V model. So now we have done with the sequential model. So two examples of the sequential model is that the waterfall model and the V model. And now we'll move to the next SDLC model, that is a incremental model. So what happens in an incremental model? Is there anyone who has already worked in an incremental model? I have seen someone commenting like they are following the incremental development model. So what happens in the incremental development model? If any of you have worked,
Anybody in our participants who actually worked in the incremental development model? Anybody?
okay. So mostly nowadays we will be like following the agile model, which is a combination of both incremental and iterative. But let's see what happens in incremental model. So what is happening in the incremental model? We will be dividing the whole application. So here we can see that the final product and the purple part, which is a final product, we are dividing the whole application into increments or pieces. And each increment will have all the SDLC phases happening. So you can see in increment 1, there is design, development, testing, deployment, all these phases happening. Again, in increment 2, all these phases are happening. So if there are n number of increments, all the development activities will be happening in each and every increment. And also the size of the increment might vary. So if we are taking a huge feature, the size of the increment will be bigger. So the size of the increment might vary with the features we are involving in the increment. So what exactly happens in the increment is the whole product is being divided into different increments or pieces where all the different development phases will be done, and all these increments combined together will get the final product. So it is very simple. From the name itself, we can understand into different increments where all the different development phases are involved. I hope
Suma,
that's clear.
we have
Is
some
there
comments. We will have some comments from the participants. Can you go through that?
node work? A basic prototype of system will be developed, and then we'll increase its capacity and capability. We can't say actually a prototype, but the whole application will have a defined requirements, and from the requirements we'll be dividing the whole application into different increments. So which might not be connected increments, like increment 1 and 2, you might not be able to integrate together and to make a good next product. So this is more like a separate pieces of increments. So we'll be dividing the whole application into different increments. Whereas in the iterative model, that is somewhat like what you have said, like the whole in each iteration we'll be we'll be delivering a working product or a part of a working software, and which grows on top of each iteration, and which will give us the final product. So in incremented model, the whole application is divided into different increments, and every increment will have all the development phases, and all these increments finally joined together will give us the final product. Is it clear?
Yeah, it's clear. Yeah, we got some response. Team, any other questions, or are we good with the incremental model? Any other questions, or are we good? Can we get some responses?
Yeah. So I think we
Okay,
can
I
move
think
to.
we are good. Yeah.
Yeah. Next is the iterative model. So what happens? So this is one of the like widely used models nowadays. So the agile specifically, which is a combination of both iterative and incremental. So what happens in an iterative model? So this in iterative model, it would be more time-boxed iterations or cycles. So whenever we go through the whole ISTQB sessions, you have to be very clear with the terms. So there can come questions like, which is that model which involves cycles, which is that model which involves linear sequence. So you have to be very clear with the terms which are being used. So here in iterative model, it could be time-boxed iterations or cycles of mostly 2 to 3 weeks. So, which can again, we can't actually say it will be specifically like 2 to 3 weeks. And the timing can change, which can again change based on the project scope. And the expectation is that each iteration should deliver a working software, which will be growing until the final software is being delivered. So, one iteration, our current iteration will be growing on top of the previous iteration. So this will go on until the final product is being delivered. So you can see that again, same like the incremental model, in every iteration or cycle, there are all the development activities happening, the development phases happening. So the intent here is we'll be delivering the project in smaller iterations, which gives very early feedback. So that is one main point we should not miss on. Like we'll get a early feedback. So you are developing a software, you are giving a demo, or you are showcasing it to the client only towards the end of the project, and then they want to make some changes. That is going to be a huge problem. So but in iterative process, you are able to showcase whatever working software you have produced in 2 to 3 weeks to the client, and then you get an early feedback. So these changes should be done, or we can improve with these features. So such type of comments and feedback you will be getting from the client. So one of the main advantage of the iterative process is like we will get early feedback. So even from the very first iteration, when we are giving a demo, they get to see a look and feel of how the final product is going to look like, and to make suggestions and feedback at the early stages itself. So that is one main advantage of the iterative process. So now we have few examples of the iterative development models. So the first one is rational. So here, what you have to check into is the duration. Like for each model will be differing based on the duration. So first we have the rational unified process. So what happens in the rational unified process? Here the difference is the increment. So here the increment or the iteration would be relatively longer, and therefore the feature would also be longer. So the rational unified process, the iteration would be relatively longer. Whereas in Scrum, so Scrum we know almost most of us will be now working on the Scrum methodology. So here what happens in Scrum? Here the iterations would be relatively short. So Scrum is one of the frameworks in the Agile methodology, which is a combination of both incremental and iterative development model. So one of the main advantages here is that we get a continuous stakeholder feedback, as we have already mentioned. One of the main advantage here is that we get a continuous stakeholder feedback to produce a high quality consumable code through user stories. So that is Scrum. So next we have Kanban and Spiral. So what happens in Kanban? So the basic difference between Kanban and Agile is that unlike Agile, Kanban does not have a fixed size. It is implemented with or without fixed length iterations. So which can deliver either a single enhancement or a feature upon completion. So the basic difference between Scrum and Kanban is that it does not have a fixed size. Next is a spiral. So what happens in spiral? So the main attraction here is a prototyping. So this will involve creating experimental increments. We'll be creating a prototype. And once the prototype is ready, we'll showcase and get a feedback. So which is very important. So we'll showcase, get a feedback, and based on that feedback, we'll decide whether we have to go on with the project or we have to abandon it, or if heavy work rework is to be done or not. So that is this spiral or prototyping will be more helpful in supporting the risk handling. So in order to identify the risk, we will be mostly using the spiral based development models. So these are different examples of the iterative development model. So we'll just go through it once again. Here, the main point is the duration. So we know that in rational unified process, the iterations are relatively long and corresponding features are also large. Whereas in Scrum, the iterations tend to be relatively shorter with a few weeks or even sometimes hours. And in Kanban, there is no fixed, may or may not have any fixed length iterations. And finally, for Spiral, we create prototype. Prototyping is the main advantage of the Spiral. So we'll create a prototype, take a feedback, and then we'll decide what to do next, like whether we should go on with a project or whether we should abandon it or heavy rework is needed or not. So is it clear till here? If there is anything, you can put it on the chat. Okay, I think it's we are good to move to the next topic. So next is software development model based on context. So we know that every company will not be using the same model, or for every company there will be some set of processes available, and there these processes are adapted to the context of the project and product characteristics. So that will differ. So which development lifecycle we have to adapt to this particular project depends on purely on the requirements for that particular project or product. So in some cases, we can see that for the same project itself, like there will be a combination. For the front end side, they'll be following one SDLC model, whereas for the back end, they'll be using some other development model. So in some cases, there can be a combination of both different models as well. So it purely depends on the context of the project and product characteristic, which development life cycle we must be adapting to. So this can vary based on the goal of the project, the type of the product being developed. So in case you are developing a admin application for a supermarket, and there is another application which is a banking application which deals with like financial transactions. So those are two extreme applications. So the banking application should be handled with high care. So depending on these different characteristics, whatever product we are delivering, the business priorities, how fast they want it, how fast they want to release it to the market, what are the different risks involved in it. So depending on all these factors, we will be choosing the corresponding SDLC models. Like we can't, okay, now we have all the process available for Agile, we'll just go on with Agile. That is not the process. We'll have a study on the requirements, the context, different criteria, the type of product being developed, everything we'll go through and then decide which development model is going to be used for this development. So again, in some cases, we both use a combination of different SDLC models as well. Yeah. So we'll do a recap of what all things we have discussed so far. So first, we have gone through the good testing characteristics. So one of the main important thing is the testing should be happening as early as possible and through every development activity. And in V model, implementing what we are implementing, unlike the waterfall model, we are implementing the principle of early testing. And then in iterative model, we'll be getting a working software in each phase, not like in incremental. So in the incremental model are in increments, but every time we might not be getting a working software. So, and on what basis the SDLC will be selected for a project, which purely depends on the context of the project and the requirements and different characteristics of that particular project. We'll be deciding which SDLC model we have to use on. So with that, we have come to the first topic in this module, that is the different SDLC models. Is there any doubt till here? Anything to be discussed? You can put on the chat.
Team, any questions? Are we good with all these different life cycles? Any questions? Anybody? Or are we good? Asna, Darshana, Hima, Riya, Niju, Pavati, Rosmi, Soumya, Shruti. Any questions or are we good? We're getting some good response. Team, any questions from the YouTube side? We have some members join from YouTube as well. Any questions from the YouTube? Let me check it. Suma, we are getting some good response, so I think we can continue.
Yeah.
We're good.
So good. Great. So we'll move to the next topic, that is test levels. So we have different test levels, like we have just gone through it quickly before. We have component testing, integration testing, system testing, and acceptance testing. So what exactly is the test level? So why do we call it a test level? So we group some activities. When we are doing some activities, we group it and call it by some name, right? So the test level is also like that. So it is a group of activities that are organized for a common objective. So we have learned in good practices that each test level is having a different objective. So based on the objective, we have grouped activities and organized and called it by some name. That is component testing, integration testing, system testing, and acceptance testing. So testing will be different in different levels, and tasks will also be performed different in different levels. So we'll just go through each and every different levels of testing. Yeah. So before we actually go to the different levels of testing, we'll just see different characteristics of the test level. So specific objective, which we have already discussed, like we have different test levels and each one have specific objectives. So for component testing, we are checking the components or the unit or the code. So the objective there is to identify the issue in the code. Whereas in system testing, the objective is to have an end-to-end testing of the application and to see if there is any functional issues. So there are specific objectives for each level. So each level is characterized by its own specific objective. And then there is a test basis. So what is test basis? So we should be writing, when we have the requirements, we'll be writing the test cases, right? So test basis means not necessarily it can be a document, it can be something something else. It can be a schema or anything. So whatever document or source we are using or we are referring to derive the test cases, we call it as a test basis. So the test basis is something we refer to derive the test cases, which can be the requirements document, which any source of information will be the test basis for that. Next is a test object. So what is a test object? What is being tested? So for example, in the case of component testing, the code is being tested. So the test object there is a code. And in system testing, we'll be testing the application as a whole. So the test object will be the application. And typical defects and failures. So there will be typical defects and failures. So for component testing, the defect will be on the code. Whereas in system testing, that would be some functionality, error in the functionality. So for each test level, there will be typical defects and typical failures. Next, we have the specific approaches and responsibility. So there should be specific approach. So we can't test we can't test in the same way. Like if the component testing, we'll be testing the code. We can't use the same approach to test a system. Do the system testing. So there are specific approaches for each and every test level, and there are specific responsibilities also. And finally, for every test level, a suitable test environment is required that we already know. So what happens in an acceptance testing? So for a software or any product, what happens in an acceptance testing? So that the acceptance testing would be done towards the end when the product is almost ready. And it is being given to the customer or the client, and they are verifying if the product can be accepted or not. That is the acceptance testing. So you are going to use an application as a user, how you are feeling. That would be the vision of the one who is doing the acceptance testing. So in acceptance testing, the environment should more look like how it will be looking for the actual website. So a production-like test environment is ideal for the acceptance testing. While in component testing, so when does the component testing happen? So we are starting with the development. The developer has created the first component, and then they are testing it. So that happens in the initial phase. So that will be component testing will be done in the developer's environment. So each test level will be having a suitable test environment, which is required, like in acceptance testing, production like environment, or how the actual website is going to look like, how the actual application is going to look like. So a production like test environment is ideal for acceptance testing, whereas for component testing, the ideal environment would be the developer's environment, where the developer would be doing the testing and finding out the defects in the code. So these are the different characteristics of the test level. So there should be specific objectives. There should be specific test basis for each test level. There should be specific test object, typical defects and failures for each test level, specific approaches, and finally, a suitable test environment based on the different test levels. So now we'll move on with the first test level, that is a component testing. So do you have any idea like what is test component or unit testing? You might have like come across the term at least in while doing the testing. What is component, or from the term itself we can get an idea what is component or unit testing? You can put on the comment whatever it need not be a proper definition of component testing, but whatever you understand from the term or what you have heard in your organization, what is a component or unit testing?
Or at least any unit testing practices which is following in a project. Any idea? The thing is, like, most of us joined today are testers, right? So testers will not be part of unit testing most of the time. Yeah.
Yeah.
But we have some responses. We'll go through that.
particular piece of
Yeah,
code, debugging the code, white box testing done by the developers, all
yeah,
correct.
yeah,
So,
yeah,
yeah. Yes.
yeah.
So yeah, so component testing, as we all know, like we'll be testing the smallest testable part of the system. So that is the smallest testable code mostly. Like we are starting with the development, we are creating the components or unit. So and then the smallest testable part is being tested by the developers. So that is a component testing. So this smallest testable part can be the code, that can be the class or method or object or program, whatever is involved. So we can take the example outside software as well. So whether it is a software or any other product available in the market, finally we are getting a product in our hand. Before we actually test the final product, there are a lot of testing activities which would have happened for each and every individual unit which is attached in that product, right? So if the case of car or car, if we take, before we actually drive and test the car, there might have been the testing going on for each and every part of that car, like the tire or the gear or whatever it is. So component testing is the smallest testable part of the system. That is the smallest testable code, which can be a method, which can be a class, object, or program, which is separately testable. So do we need test cases for doing the component or unit testing? Do we actually write test cases? Yes. Is there any other response?
Yeah, in some projects, I also like JUnit test cases are used for component testing. I mean, unit testing.
Yeah, right. So we know that the component testing is done to verify the lowest independent entity in a software program is working fine or not. So this will be mostly done by the developers, right? So the developers will be coding and then they will be doing a component testing or the testing of the code, whatever they have written, and find if there is some defect or not. So the developers will be doing it in their own environment. So there is no need of a formal test case writing, but in most of the cases these days, the developers develop the JUnit and NUnit test cases. So because it is always a good to have documented everything. So ISTQB is not mandating the test cases, but in actual projects, developers develop the JUnit test cases, which is always a good to have. So the component or unit testing, where each module is tested individually and it follows a white box testing. So what does a white box testing means? We can actually see the internal structure. We have to actually know the internal structure of the program or logic of the program to actually test it. So there should be a proper knowledge of the programming or coding to do the component testing, which is why it is mostly done by the developers after coding. So there are different terminologies used for the component testing as such, like the component testing or the unit testing or the white box testing. So we'll
And
just
Subha, one
yeah,
more point that we need to emphasize in terms of component testing. So in unit
yeah,
testing or component testing, we are testing only the code, not the functionality which is behind the code. So we'll be
right.
focusing only the code here, code quality,
Yeah,
not the functionality.
yeah. So
Okay, all good.
yeah, so if we are like if we take the example of an e-commerce website, we are everywhere aware of this. Like we have different functionalities in e-commerce website. So when you click on a button or when you click on an add to cart button, what is your expectation? We are expecting that the product should get added to the cart. We don't actually have to see what is actually happening behind. So that is a case for the system testing. Whereas in the component or unit testing, we have to actually see what is happening in the code. So the in component testing, we are not looking at the functionality, but the code. So we'll next move to the objectives of component testing. So each test level have its own objectives. Like we have already discussed, for component testing, the objective is to find out the issues in the code. So these are some common objectives of all the different levels of testing. We'll just go through that to reduce the risk, of course, verifying whether the functional and non-functional behaviors of the component. So here the point is we are verifying the functional and non-functional requirements of the component. And then there is building confidence in the component's quality. Of course, any testing activity we are doing to build the confidence and to reduce the risk. And finally, to find the defects in the component. So these are the different objectives of the component testing. So next, like we know that like the component or unit testing is the first step, first level of testing. So here small testable code or each code unit is isolated and tested to determine whether it is working fine or not. So it can happen in some cases that we in order to, if we take the example of the e-commerce website, we need to test the payment page. We know that for in every e-commerce website, there will be a payment page where we'll have to do the payment and then check out. So if you need to do the verification or testing of the payment page, you need a response from the bank's website, right? So you are giving the UPI ID or your bank details on the payment page, and then it goes to the bank's server, bank's site API, and then we have to get a response back. So during the component testing phase, like we might not have done the integration from the bank's side, right? So in such cases, we need a substitute. Like we need a calling function. Some of the modules might be missing. So if we need to test a module A here is a payments page, you need a response from the module B, that is a banks page. So and the banks page is not yet integrated to our payment page. So in such cases, when you are doing the component testing, there will be places where you will have to put the dummy response. So in order to do the payment page, there can be different set of responses. Like when you are giving the bank details, bank might come back saying that your account details are not correct, or sometimes it will be like server is not responding, or sometimes it can be yes, verified, you can proceed. So there can be different responses. So while doing the component testing, we might have to face such situations where we need the response from other systems or other modules which is not yet developed. So here the F is a unit under testing. For doing the test here, we need response from some other modules which is not yet developed. So in such cases, we create dummies. Dummy response, like we create a dummy response, like the user is verified, user is not correct, user ID is not correct, server is down. Or we create all these dummy responses and then do the component testing. So while doing the component testing, we might have to face such situations where we need a response from another module or another system which is not yet integrated or developed. In such cases, we use the dummy modules. We call it as the stub and the drivers. So if a main calling function is missing and we are creating a dummy for it, we call it the driver. Or if a subsystem or sub module is missing and we are creating a dummy for it, we call it a stub. So we have stubs and drivers to do the component testing. So we can take the example of the payment page always, like to remember and make it clear. Like, so to do the testing of the payment page, we always need a response from the bank system, which is not yet integrated. So in such cases, we create dummy responses there and do the component testing activity. Yeah. So what are the main points here? Like it is each module is tested individually and follows a white box testing method where we need to know the internal structure or code, and it is normally done by the developers. And there is no formal activity of test case preparation, but it is always good to have that the developers create the JUnit test cases. So Is it clear till here? Is there anything missing? Any doubts?
Yeah, so we have a question there.
Here we say as first level is component testing and second is integration testing. Then where will sanity and smoke testing? What level? Could you please explain on this? Because it's very confusing sometimes. So smoke and sanity, like if you are, we are already working on a project, we might be knowing what is smoke testing. So whether it is a full application or a build which is available to us, when we are asked to do a smoke, what are we supposed to do? Like we know that if it is a hardware, what does it the smoke testing actually means? We are plugging on the current and seeing that there is no smoke coming out. There is the basic thing happening, working fine or not. So the smoke testing is when we are given a module, we are verifying that the system is stable or not. We are just verifying if the system is stable or not. That can be the basic functionality, whatever is involved in that build. So
Okay.
you are given an
So
application to test. Yeah.
basically, before jumping into that smoke or sanity explanation, so first we need to set the context. So we were discussing about the levels of testing, right, in these topics. So actually, these smoke and sanity will come under the different types of testing, not the levels of testing. So under these levels of testing, that we can accommodate these different types of testing. There can be different types. Um, Smoke will be there, sanity will be there, regression will be there, and retesting will be there. All those different types of testing that we can incorporate in different levels of testing as well. I think Parvati is confused in between levels of testing and types of testing. Yeah, now maybe we can get into the explanation of what is smoke and
Yeah.
sanity.
Yeah. So, so for every different, if you go on Google and search, you can see 100 and more types of testing. So types of testing is different. And for every type of testing, there will be a different test levels. So if we are doing a functional testing, there will be a functional, there will be different levels for the same functional testing. So we'll be having a component testing, integration testing, system testing, and acceptance testing for the functional testing type. And for the non-functional testing type also, we can have different levels. So the test types and test levels are different. For every test type, all the different test levels will be involved.
Yeah, I
Is it
think
clear?
Parvati is clear. Yeah. Parvati response is clear.
Yes. So next
Uh,
we have the integration test.
1 second, Suma.
Yep.
It's already, we close 5 minutes. The schedule time is up to 11 o'clock. Is it okay that we continue 10 more minutes, or we really want to have a hard stop here? What do you think? We got one okay,
Okay.
okay, two okay. Okay, I think our crowd is okay to continue for next 10 more minutes. Maybe Suma will continue for next 10 more minutes, and we'll wind up in 10, 11, 15.
Yeah, sure.
Yeah,
So now we have discussed about the component testing. That is the first level of testing. You are testing the code or the program or the module, whatever it is. So now we have the different modules tested. Now we are integrating the different modules. So say you have the module A and module B. So you are integrating the module A to module B and is verifying if the interface or the communication between these two modules are working fine or not. So when you are saying module A and module A will be having an individual functionality which we are not checking. That would have been already carried out during the component testing phase. So module A will be having an individual functionality, module B will be having an individual functionality. We are not checking that in the integration testing. In integration testing, we are integrating these two modules together and is verifying if the communication or the interaction or the interface between these two modules are working fine or not. So in this case, we call it as a gray box testing because both functionality and the code is tested. So we call it as a gray box testing. So again, same like the component testing, there are some objectives for integration testing level as well. So some common objectives, same like before this, to reduce the risk, to build the confidence in the quality of the interface. Like in component testing, we were doing the test to build the confidence in the code, whereas in integration testing, this is done to increase the confidence in the quality of the interfaces. And here the functional and non-functional behaviors of the interfaces are specified. So, and again, the finding defects, which may be in the interfaces themselves or within the components of the system. So here, we are not trying to find the defects in the code or in the component or the module as such. We are trying to find the issues when two modules are integrated together. The integrated functionality is being tested and the defects are found out. Next is a integration testing level. So we have component testing, we have integration testing. Now the integration testing as such is divided into two more parts, like the component integration testing and the system integration testing. So what happens in the component integration testing? Here, the focus will be on the interactions and interfaces between the integrated components. So this will be performed after the component or unit testing is done. So after component testing, two modules are integrated and the interaction between these two modules are tested, and then we call it as a component testing. So we know that in some website too, there'll be like the country drop down. There'll be a country drop down. When we select India from that country, we get the corresponding states or districts. So if we select Kerala, there'll be another drop down with the district. All the districts in the Kerala will be available in the district drop. So this is an example of the component integration. So there'll be two different components. The component testing would have been already done. And once the component testing is performed, these two components are integrated together, and we are focusing on the interactions and interfaces between these integrated components and finding out if there is any issues. So that is a component integration testing. Similarly, same we can take the example of the credit card also. So when we select the credit card option from the payments page, we can see that there are so many options available, like the Amex, Visa, Master. All these different options would be displayed. So these are different examples for the component integration testing. So next is the system integration testing. So what is a system integration testing? Before we have actually discussed this, like there is a payment page. You need the response from the another system. The bank's page is entirely a different system. So when two different systems are integrated, and we are making sure that whatever response is coming from the bank's page, whatever integration is supposed to happen between these two pages is working fine or not. So when two systems, here the focus is on the interaction and interfaces between the systems or the packages or the microservices, whatever is involved. So this will be performed after the system testing. So a component integration testing will be done after the component testing, whereas a system integration, if we need to do the system integration, we need to have the system as such, right? So the system integration will be done mostly after the system testing. So we have the example of the e-commerce website payment page. And for system integration testing also, we have different approach. That is a big bang integration testing and the incremental integration testing, which is again divided into top down or bottom up approach. So what happens in the big bang integration testing? So we have heard this word like many times, like what is big bang? So here we are assuming that all the components, all the systems are integrated simultaneously. So for the application, whatever components or systems are involved, all these components are integrated simultaneously. So those components will be integrated simultaneously, and after which everything is tested as a whole. As a whole, the application will be tested. So what is one advantage of the big bang integration testing? Here, every component or module is developed before integration testing. It need to be developed, right? So in order to do the big bang integration testing, every component should be readily available. So since all of these components are available, there is no need of dummy like stubs or drivers. So the Big Bang integration testing says that all the components are integrated simultaneously and then tested. So the advantage here is that in order to do the Big Bang testing, all the components should be available. So we don't have to actually go for the dummy, that is a stubs or drivers. One disadvantage is that will be difficult to trace because the testing is done like where if there is some issue, it will be very difficult to trace the cause of that failure because we will be having all the components ready and then we integrate all together simultaneously and then only we will do the testing. So we can't actually trace where exactly the issue is happening. So that is one main disadvantage of the Big Bang integration testing. And next we have the incremental integration testing, that is that can be the top down approach or the bottom up approach. So what happens in the top down approach? All the system are integrated one by one from the top. So the system is integrated one by one from the top and the testing is done after every integration. So we'll be integrating one by one from the top and after every integration we'll do a testing. So we after every integration, we'll make sure that whatever we were expecting, whatever expected output is there, we are getting it. And in case if there is any defect or after the first integration, we'll not jump into the next integration. We'll clear the defect, we'll fix the defect, then do a retesting, and then only we'll move to the next integration. So the advantage here is that the defects would be found very early because after every integration, after every increment integration, we are doing a testing. So the defects can be found early. The problem with the Big Bang was that it is very difficult to trace the cause of failure, which is not a problem in the incremental integration testing. So here the defects will be found early and easy to find the root cause because only 2 modules are integrated or only 3 modules are integrated. It is easy to identify what was the root cause of those defect. And the disadvantage here is that it will be time consuming because if it is a top down approach, we will be starting from the top, integrating one by one. So we might need the dummy modules because we don't have all the components ready. It's like the Big Bang integration. We might need stubs or drivers. So if we are following a top down approach, we might need stubs, whereas if you are following a bottom approach, we might need drivers as well. So for top down and bottom up approach, the main disadvantage is that it will be time consuming because we are doing every integration, we are doing a testing, we are going on with a fix, and then only we are integrating the next module. So it is quite time consuming and stubs and drivers are also required. So that is the difference between these 2 different approaches which is being followed for the system integration. So first level was the component testing, and next we have the integration where we check once the 2 components are integrated, we make sure that the communication between these 2 components are working fine or not. Again, we have 2 different types of integration testing, that is the component testing and the system testing. And in system testing, we have 2 different approaches, the Big Bang integration testing and the incremental integration testing. Is it clear till here? Any response you can put on the comment? Okay. Okay, John.
Hey, I think we are good.
Yeah.
Yeah, Suma, I think we are on time. It's 11:16.
Yeah. So now we have stopped till integration testing level, and next session, next part, we'll start with the next level of testing.
Okay.
Yeah.
All right. So we'll continue the session by next Saturday, same time, 10 a.m. So thank you all. Thanks for joining,
Thank you.
and good day. Happy weekend. Thank you.